Alrighty, I think we're going. Hello, people. All right, so, ooh, this is like way too big, Caitlin. Is that better? Caitlin, is that cord bothering you? I just realized there's a cord there.
No.
It's okay?
Yeah.
At least it's white. Okay, so optimization problems are problems which involve finding the maximum or minimum point, the turning around points. Okay? And turnaround points of functions are relative maximum or minimums. The tangent lines at these points are horizontal and slopes of 0. So we'll be taking the derivative, looking at both the numerator and the denominator, seeing what numbers we get when we look at those, when we set them equal to 0, and go from there. Does that make sense to everybody? So these are the word problems. There's kind of things you have to take a look at. Usually I've found out that we struggle a bit dealing with word problems. Do you know why? Because there's words in them as opposed to symbols. The very first problem I give you is the height function. And this is kind of a review because somebody said, I think it was Aiden the other day, you asked me about this. It might have even been yesterday. 2 days ago? Last Friday, okay. So is it all right that I call on you? Okay. So example, h of t equals a negative 16t squared plus 5t plus 20 describes the height of an object if the object is released with an upward initial velocity of what? 5 what? Feet per what? Second. Beautiful. And it's positive because it's going up, correct? If I would throw it down, it'd be a negative 5t. Would you agree with that? Okay, super. Let's keep going since you're right. From an initial height of what? 20 feet. Everybody okay with that? So then I said, okay, I made a table here. At 0 seconds, I'm at 20 feet. Somebody's calling me right now. Okay, hang up on them. Alrighty. I got my hearing aid in. My right one's not working, which I don't know. So I can hear Jack. I can't hear Caitlin. I suppose I can hear Ty, but I can't hear Alexis. It's kind of a bit, but I'm a little bit closer to them, so maybe it'll work out. So, then when I put in a half, I got 18.5, and then I put in 1 second, I got 9. Now, here's my question. Do I have an idea when I might have been, is 20 feet the highest this was? No, Caitlin, you're saying no, it wasn't. Why?
Because it was tossed upwards.
It was tossed upwards. So it must have reached its height between what 2 times? Because the start here it's 20, and then it's at 18.5, and then here it's 9, and all these numbers are going down. So when did it reach its height, do you think?
Probably between 0 and a half.
0 and a half. I would agree with you. So when I draw my graph here, here's 0, here's a half. Oops, I don't know why I drew a negative symbol. Here's 1. And so right here I'm going to say 10 feet. Right here I'm going to say 20 feet. Right here I'm going to have 9. Right here I'm going to have, about 18. So it must have went up here a little bit, correct? And then started going down. Does that seem right, Caitlin?
Yeah.
What we imagine? Something like that? So Alexis, it says, notice there is an optimum greatest height. There's a spot here, right? Where I have a beautiful horizontal tangent line. Okay, and can be found by taking the derivative. So what is the derivative? Alexis.
Negative 32 32t
Negative 32t what?
to the first power.
Anything more?
Yeah, plus 5.
Plus 5. And what do we call that derivative?
H prime of t.
What's another name for h prime of t in this specific case? You're not when you take the derivative of the position function, you get
You get the velocity.
velocity function. Very good. And so this thing is tossed up at 5 feet per second. It starts slowing down, slowing down, slowing down, slowing down, comes to 0, right? So, Allison, I have to make this negative 32t plus 5 equal to what? 0. And I get t is equal to what?
5 over
Yeah, 5/30 seconds is what we called it in Kruger welding. So this would be 5/32 seconds, which I think is hilarious. I laughed, and the other math people, we were all together, said, "You are such a nerd to think that's funny." And they hurt my feelings. Okay? All right. If I want to figure out the optimum height, the greatest height, what am I going to do with that 5/30 seconds, Justin? Put it back into what function? The normal function. What's an abnormal function?
The original. I'll call it that.
Did it have a name, the original function?
H of x.
So I'll put 5/30 seconds into H. Oh, I don't know how many of you shoot it. Remind me, I have something to show you guys. I came across a picture of what we're talking about. It's on my phone. And I don't have my phone. I don't think I have my phone. You want to wait? I'm so excited. I want to show it to you. Just wait.
Yo, someone go up there with their face in front of the camera and then lock it and like freeze it.
Do it.
Oh, and freeze it. Oh, yeah. I kind of want to, but it's too late. Like he's right in that office. He'll see me do it.
Never show you, Oh, it's right here. Isn't this class? Oh, what happened here?
I've been exposed.
It starts out as corn. Oh, excuse me. Did you know corn is actually a grass?
Big brain.
Yeah, it is. I'm right, aren't I? It's amazing that's because I'm an honorary member of the FFA. I've written about the FFA and Fibonacci sequence in my blog. I haven't written in my blog for years, but I had a blog I used to write. So it starts out like this, and then when you take the derivative, it becomes corn. And when you take the derivative of corn, it becomes popcorn. Oh, I laughed and laughed and laughed. So anyway, Justin, did you figure out what you get when you put that in there?
I'm working on it.
Okay, you want me to tell you? Let's see if I even know. I think I did it. Owen, did you figure it out yet?
Yeah.
What'd you get?
20.391.
I think that's what I got too. 20.391 feet.
Yeah.
Yeah, I also think I came up with, did you come up with a fractional representation for that, Owen?
No.
I think I did. I bet you I can't find it. Yeah, I don't think I.
Oh, yeah, 1,305 over 64.
Say it again.
1,305 over 64.
224.
1,305 over 64.
Really? Yeah, that's what I got too. Yeah, that's right.
Big brain.
Very good. You did that in your head, or did you use the machine?
The machine.
I did it in my head. I didn't do this part in my head, because that's like, but I did this part in my head. All right. All right, so here's a problem from okay, how old was I? What year was I 22? I was 22 in 1980. In 1980, I'm going to get married. I had my first teaching job. And so I'm back working in my dad's welding shop. And I have to do this problem. I go, oh my God, it's a calculus problem. So what we're going to do here is I'm going to show you 5 steps that you should, when you do these problems, I'll bring you to success, okay? And the first one is to draw a picture as you can. And most of the time you can. There's a few times you can't. And so this is my dad's drawing, all right? And there's a piece of metal. And we had this thing that I cut out this piece of metal, and it was 20 inches by 20 inches. And then we had a machine called the nibbler. You know what it is?
Yeah.
How do you know the nibbler?
So I did metals class.
Do they call it the nibbler in metals class? Oh, okay. I thought there was a real official name. But it sits there and just punches them out, right? And so, and I can't remember the gauge of steel we could use, but it wasn't like it was real paper thin. It was fairly substantial. And so what we would do is nibble out these squares. And all these squares are the same. And so this is where the pretending comes from, Owen, because of my poor drawing ability. And so I get something that looks like this. Okay, has everybody got that? And then we had a machine. We didn't use a hammer. We had a machine that we could bend it here. Do you have a machine that can bend it? Oh, wow.
Great.
We could have Kruger Welding here at Sauk Rapids. And then it ends up being a tray that looks like this. Does that make sense to everybody? And then we would braze these corners so they were sealed. That's the best I can draw right there. My dad did a beautiful job. My dad and my younger brother Bruce are very, very good of drawing stuff. My dad would see a picture of any piece of furniture, and he could replicate it by just looking, knew what the dimensions would be and all that type of stuff. Okay? So, Eden, in this problem, it says an open box of maximum volume is to be made from a square piece of material that is 20 inches on a side by cutting equal squares from the corners and turning up the sides. Find the maximum volume. Okay, here's my question. What is trying to be maximized? Volume. Okay, so I'm going to write the formula for volume, or you're going to tell me what is the volume of this is a rectangular prism. Would you agree with that? So what's the volume of a rectangular prism?
Base times height times length.
Will you say it one more time?
Base times height times length.
Okay. Can I go length times width times height? We said the same thing, but are you okay with that? This is going to be our primary function. This is what we're going to take the derivative of. However, right now to take the derivative of it would be god awful, Julia. we want to have, this right now has 1, 2, 3 independent variables, and I only want one. And I'm going to call that one x most of the time. Is that okay with everybody in here? Okay? So let's go to the next page. So it says, write the primary function so that it's in terms of one independent variable. So I'm going to come back to my picture and I'm going to take off this amount, right? And since these are squares, I can call this x and I call this x. And if I call this x and this x, because they're all the same. So maybe I'll take off a half an inch. Maybe I'll take off 2 inches. I don't know. I want the maximum volume. So Ryan, how are we doing? You look, basketball practice has started? You look tired. Are you at practice in the morning?
Yeah.
I could tell. I heard the ball bouncing when I came, right? And you're sleepy. You're exhausted.
Yeah.
Okay. Did you do a lot of running?
Yes.
You know what the best thing I could do in basketball? Foul. And I was really good at line drills. And I was really good at tackling, but it's not allowed in basketball. Did I tell you that story? That's the basket. Opposite end of the court. Here's me. I'm tiny. Here's John Anderson. He's not. Okay, he's a foot taller than me. Here's the coach. He rolls the basketball this way, just rolls it. Okay, here's the half court line. The first person to score wins. What do you think I did? John went after the ball. I did not. I went after John. Over here are the bleachers. John ends up on his butt on the bleachers. I go back, pick up the ball, score and win. He complains. He says, he hit me into the bleachers. Coach says, yeah, but he's a midget. End of story. Okay? Elijah, you almost smiled. One of these days, I might even see a guffaw. Do I have to tell you what a guffaw is? Laughter. Very brief laughter. Like, ha! It's a guffaw. All right. So, whose turn is it? Ryan, is this still 20? What is it?
20 minus 2x.
Okay, is it 20 minus x or 20 minus 2x?
20 minus 2x.
Yeah, because I take off 2 chunks, correct? The left and the right. So this is 20 minus 2x. What's this?
20 minus 2x.
Why? Because it's a square, right? Started out a square, it remains a square. It's just a smaller square. What is this? What?
X.
X, because this is x here and it gets folded up, and this is x here and they match up, right? So this is x. Okay, you got that? So, v of x. It's now I'm writing it in functional form. You tell me how to write it.
Let's see. 20 minus 2x. Minus 20 minus 2x.
Oh, really? You're going to make me write 20 minus 2x times 20 minus 2x? Come on, be nice to me for once, please. Owen's whispering it so I almost can hear it, and one of my hearing aids is gone.
Is 20 minus 2x squared.
Times what?
Times
That's length and width. Now I got to multiply by the height. What's the height?
x.
x. Perfect. Can I do that? Okay, now, you have to have your domain. What does my domain look like? Elijah. Can be any number? Can be negative?
It's gotta be less than 20.
It's gotta be less than 20. I say it even has.
Gotta be less than 10. To 20.
You weren't 100% sure, but 10 is correct. Why does it have to be less than 10? Besides that, Owen maybe either told you or gave you telepathy.
Right? Because 10 is half of 20, and then there's 2 x's on each length. So like,
Right, if they both come in at 10, I just ruined my thing, didn't I? Right? And so it's got to be somewhere between 0 and 10. Okay, so what I'm going to do is I'm going to graph this baby. Okay, oh, get your calculators out, everybody, because you're going to need them today. So Ryan said x times 20 minus 2x squared, correct? Right? I like this calculator because you can see it. There are other reasons, but, and then I'm going to go to the window, and I'm going to go from 0 to 10, and I'm going to go about 750. I'm guessing. Sure enough, that works. And so this is the size of the square I'm put down. This y values represent the volume. Would you agree with that? And so there is a maximum volume. There's a highest point for the volume. Everybody okay with that? You didn't get this, Caitlin?
no, I'm trying to figure out my scales. I can't see the top part.
Oh, yeah, just make it to 750. Did it work if you made it 750? And then I go up by tens. I don't go up by ones.
That makes sense.
Or 50s. You can even go by 50s. Ones are overrated. Did it work out for you? Okay, so here's my graph. Here's 0 to 10, right? Here's my velocity, and here's the length that I'm taking. And you can see from 0 to 10, I'd have 0, just like what Elijah said. Okay, I'm going to go to the table. You should know how to go to the table on your calculator. And is everybody in here on Ask for TI people? You guys know how to do Ask on TI or not? I think I did it like the very. Do I need to remind you, or are you okay on it? What?
It's just my permanent setting. I don't know how to get through it.
Okay. You go to second window. You want to make sure.
And then it says independent ask.
Yeah, that's what you want it to be.
Yep.
It looks like that. Okay? And so here's mine. Now, Owen. I'm going to write down my table here. 1, 324. 2, 512. 3, 588. 4, 576. Okay, do I need to look at 5, 6, 7, 8, 9, 10?
No,
Why?
that goes back down.
Because it's going back down. Would everybody agree with that? So I'm pretty close to 3, it looks like, right? Looks like my maximum is close to 588, correct? Okay, Jack. Step 5. Determine the relative extrema. What do I mean by relative extrema? Okay, and it's in the form of a,
What? Form of what?
that's what I'm asking you. That was my question of you.
Oh, I'm unsure.
You're unsure? A point.
Oh,
So it's got to be in the terms of x comma v of x. Does that make sense?
yeah.
Okay. So it says you have to find the derivative, Jack. So this is what we have right now. And Jack, how would you go about taking the derivative of that? How would Jack do this one?
Just take the derivative of each one. So like take the derivative of x and take the derivative of 20 minus 2x squared and just, here, let me do it quick.
No, you tell me.
Okay.
So would you take the derivative of this, which is 1,
Yeah.
and then you're going to take the derivative of this and get what?
40 minus 2x.
40
4x.
minus...
4x.
Where does 40 come from?
2 times. Oh, you put the 2 in front from the derivative. Or am I just doing it later on?
No, I'm just... We got to be able to do this one. I want to make sure you do it right.
Okay.
And that you don't do voodoo calculus. It's hard to do voodoo calculus because you're learning calculus.
I think I'm probably doing this in a voodoo way, so I'm unsure.
Okay, you're unsure. Okay. So who do you think is sure in how they would do this?
Probably the person behind me.
Okay, Owen, how would you do this? How would you go about solve this?
I would
Just
boil.
Okay, expand it.
Yeah.
So I would rewrite the volume function. Is that what you're saying?
Yeah.
And I would get 400 minus 80x plus 4x squared. Does that look correct?
Yeah.
And then v of x is equal to, can I write it as 4x cubed minus 80x squared plus 400x? Does that look okay, Owen?
the derivative of that.
Okay, does that make sense? Okay? So thank you, Owen. Okay? Could you have done the product rule on this, Owen?
Oh, yeah.
Yeah?
I know.
Okay? Because that's what the other class wanted me to do, the product rule. Okay, so what's the derivative of this, Jack?
12x squared minus 160x plus 400.
Okay? What's our next step?
Equals 0.
Okay, Jack, would be your next step to solving this?
Subtracting 400.
Nope.
Oh. I'll take out an x. Or no.
Nope.
Uh,
Can't.
Take out. I was gonna say something.
Because let's say I said you cannot use a calculator on this. And I said you got to solve for x without a calculator. How would you do it?
I'd probably get it wrong.
Well, I'm trying to avoid that. Okay? I need to know how you would do it and then correct you.
Well, so not subtract 400.
Yeah, that you don't want to do that.
Yeah, that's not.
That's headed the wrong way.
Um,
It's a very popular wrong way.
um,
Can I make these numbers smaller?
if you take out a,
Can I divide them by something?
um,
What goes in 12, 16, and 40? I'm just looking at the first two digits.
a
4.
4.
I'll divide everything by 4. This becomes 3x squared. What's this become?
Um,
16 divided by 4.
40.
What?
40.
40x. What's this become?
100.
100. Okay, 0 equals. you want to factor this, Jack.
Yeah.
What are the only two things I can multiply together that give me 3x squared?
3 and 3x.
3x and x, right? That's the only way that can work out. So,
I'm gonna guess and say -10.
yeah, I would.
10 and -10.
Let's take a look. A negative 10x for the inner. A negative 30x for the outer. Gives me a negative 40x. Very good. So that means x equals what?
10. Or,
X equals 10. X equals what else?
10 over 3.
10 over 3. Okay, so let's take a look at this. I believe this is what Elijah gave us, right? So am I going to eliminate any of my answers? 10. 10, it can't be 10, can it? Now, did I tell you AB, you have to consider it and then eliminate it? Does everybody understand that? All right, so I've got my x value. I got to figure out my v of x value, correct? How do I do that? You're doing wonderful, by the way. Okay.
You plug it into
And so you're going to plug it into here, correct?
Yep.
And did you already do that, Owen? Doing it right now. I've already done it. Can I write it down? I have 592.592. So my maximum volume happens when I cut a 3 1/3 inches off, and I'll get a maximum volume of 592.592. Now, that's the end of the problem for us. It's not the end of my story, because I had to convert these to gallons, because somebody's going to go buy them, right? So I divide this number by 231. And I know it goes in there at least 2 times, correct? Can't go in there 3 times, goes in there 2 times. So my dad said, well, how many gallons does it hold? I said, 2 gallons and about a pint. The pint was a lie. I had no idea. I knew it was more than 2 gallons. So I went about a pint. You know, which is 16 ounces, which is 2 cups, right? All you cooking people know that, right? Right? Do you know how many teaspoons are in a tablespoon? 3. How do you not know that? I suppose she has conversion charts all over the walls. Is that right? Or you get to use the machine to find out?
But we just have tablespoons and teaspoons. So.
Well, don't you ever have to make the recipe smaller or bigger? All right. Julia, minimum sum of 2 positive numbers and the product of which is 100. Yes.
You gotta finish your story.
What was my story?
2 gallons in a pint, and then what?
I just said that was it. That's what I said the answer was. I don't know if I knew it was more than 2 gallons. I don't know if it was exactly 2 gallons in a pint.
Question.
Yeah.
Don't you just find the maximum on your calculator?
Yeah. And you know how to do that, right?
Yeah.
Okay, this is calculus also, so you have to do these problems sometimes without a calculator. Okay? Right? Okay. But yes. Okay, Julia, find the minimum sum of 2 positive numbers and the product of which is 100. Okay? What are we, this one has no picture, because you can't draw a picture of 2 numbers. What am I trying to minimize? I'm trying to minimize the what? Read the thing. Find the what? Sum. I'm going to call sum S. Okay? And I'm going to have how many numbers? 2. I'm going to call one of them X. I'm going to call the other Y. I know they both have to be positive. So this is going to be my primary function because I'm asked to minimize it. So this is what I got to take the derivative of, except I want to get rid of y. Because I don't want to take the derivative, I'll end up getting dy dx. I want one variable. On all these problems, I want one independent variable. They give me some more information. The product of those two numbers is 100. So the purpose of this information is to get rid of y. To replace y with x. So what's this equation, Julia? The product of which is 100. Equals what? Say it louder.
Y plus X.
Is y plus x is plus a product. What? It says product.
Oh, so multiple.
So what would I write here?
X,
xy.
Y.
Okay? Right? So it could be 5 times 20. Correct? It could be 10 times 10. It could be 4 times 25. It could be 1/10 times 1,000. Correct? So I want to replace y with x, so I'm going to get y by itself, and it's going to equal what, Julia? 100 over x. So now I can come back here, and I can create a function called s of x. And s of x is going to be x plus 100 over x. Because this is what we replaced y with. Is that making sense? Now the function is in terms of x. So when I take my derivative, Landry, what am I going to get?
1 plus, I do quotient rule.
No. You got constant up here. When you take the derivative of the 100, you're going to get 0. Right? This is the same as this. 100x to the negative 1 power. Correct?
Oh, negative 100 x to the negative 2
Which is the same as the negative 100 over
x squared.
x squared. When you have this situation, what I want you to do is make this so it's one fraction. In other words, 1 is the same as x squared over x squared, correct? So this derivative can be rewritten as x squared minus 100 over x squared, because the solution could come from the denominator since this is a derivative, right? It could. So we have to consider it. Does that make sense? So x equals 0 is a critical number because it makes this denominator 0. However, we look at our domain, can it be 0?
No.
So we cross it out. Is everybody following that? Alrighty. So Landry, what am I going to make 0 next?
X is equal to negative 10 and positive 10.
Ooh, you just solved that in your head. Positive 10, negative 10, correct?
And x can't be equal to negative 10, so x is equal to 10. And then you plug the 10 into the y with the y formula, so y is equal to 10.
So S of 10 is going to be 10 plus 100 over 10. Is that what you're saying? So my smallest sum I can get is 20. You said that so quickly and so elegantly, I couldn't keep up. Ty, you doing okay? You following along?
Yeah.
Let's turn the page. Ty, in calculus, we start with easy problems and then we make them more complicated. Okay? Just what you wanted to hear, right? Okay, this has got a little Wabash County in it. So when I type this up, I shifted gears. See if you can pick it up. I will read it out loud. Okay, Ty?
Yeah.
I was going to make you read it out loud, and then I read it, and I go, oh, it's got Wabash County in it. And so I need to get in my Wabash County mode. You know what I mean by Wabash County? That's the county I grew up in. Okay? There's a little town called Wabasha. Hence Wabash County. Example 4. We need to enclose a field with a fence. I'm going to tell you right now it's rectangular. I forgot to put that in there too. Okay, you ready? Here it comes. We have 500 feet of fencing material and a building is on one side of the field, so won't need any fencing. I'll say it again in case you didn't hear the Wabash County. Okay. We have 500 feet of fencing and a building is on one side of the field, so won't need any fencing. Can I make that any more confusing? So over here, here's my building. Like maybe it's a barn or a shed. Or let's say you're housing your child and you live on a corner of a busy street. And you only have 500 feet of fencing and you don't want your oldest son to die because you're not willing to sacrifice the oldest son. So you build with your father a chain link fence that comes out this way and it's attached to the building. And then it goes this way. And then comes back to the building. So this is the only place that has fencing because the kid can't go through the house. He's not Superman. And if he was, I just have to fix the house, right? Or put a door in there or something. Or maybe a little dog door. I should have thought about that, actually. That would have been cool. All right, you got it? That makes sense? Okay, so there's my drawing. This is my fencing. Okay? So, what is it that I'm trying to maximize, Ty?
500 material.
No, read the whole. I'll read it again. Determine the dimensions. I'm going to read the last statement. Determine the dimensions of the field that will enclose the largest area. Area. So I need an area formula of a rectangle. Do you know the formula for area of a rectangle?
Length and width.
Length times width. Beautiful. Okay? Which way is length for you? This way?
Yeah.
And you're calling this width?
Yeah.
Okay. One of those is going to be x. You tell me which one.
Width.
You're going to call this x? So this has got to be x too? Okay. What are you going to call this? Can you call it y? Okay, I'll call it y. So this area is length, which is y, times width, which is x. So I'm going to call it xy. Would you agree with that? Right? You said it's length times width. My length is y. My width is x. And I can write it. Math people are into the alphabet order. Okay? You can call it yx, I won't care. Right? But I do care that there's a y there. So I got my fencing. It's 500, correct? I want to come up with an equation that I can get rid of that y. Because this is what I'm going to take the derivative of. Because this is what I want to maximize, correct? Is that making sense?
Yeah.
The 500 is just given so you can get rid of y. So if I would measure all along here, this would have to be 500, correct? What am I going to write over on this side?
X times y.
What?
2x y.
2x. You want me to multiply?
Yeah. Or plus y.
Plus y. So x plus y equals 500. 50 plus 50 plus 400 equals 500. 100 plus 100 plus 300 equals 500, correct? 1 plus 1 plus 498 equals 500. Are you okay with that? So that means y is equal to what?
500 over 2x, which become
500 what?
over.
Nope. This says plus.
Oh, I'm sorry, minus 2x.
Okay? So now I'm going to come create my, and I got x times 500 minus 2x. Caitlin, did that make sense? Caitlin, you're now going to take the derivative. But before we're going to take the derivative, anything you want to do first? Or you want to leave it like it is?
Simplify the 500 minus 2x and bring out 2.
Oh, you want me to do that? Okay. 2x times 250 minus x. How do you... Okay, you're going to take the derivative and you want it to be like that? Okay, how are you going to take the derivative then?
So it'll be so it'll be 2 times 250 minus x.
Okay. X. So you're going to do the product rule?
Yeah.
2 times 250 minus x, okay, plus, right?
Yeah. Plus 2x times -1.
Okay. So that gives me prime of x is equal to 500 minus 2x minus 2x. Would you agree? And it's equal to 0?
Yep.
So that's 500 minus 4x. So what is x equal to? $125. 125 what? Feet. Now, somebody in here might have multiplied 2x, might have taken simply x times 500 and x times 2x and gotten the same answer. Does everybody understand that? You would have still gotten this. This is just the way she chose to do it. Somebody could have chose, I'm not going to use the product rule, I'm going to multiply through, take the derivative and solve. Would have been just as correct. Okay? So now, my dimensions are, I got to figure out y. Is that correct, Caitlin? So I have 500 minus 2 times 125, correct? What does that give me? 250. 250 feet. So this is 125 feet, this is 125 feet. Add them together, I get 250 feet. Add this to 250, I get 500. So my dimensions are 125 feet. Does everybody know that's the symbol for feet, that single mark?
Yeah.
By 250 feet gives me a maximum area, I believe, is 31,250 square feet. Is that right, Owen? Because you're always checking my answers, right? I always can count on you to do that?
Maybe sometimes.
Sometimes. Not today. Everybody okay on that? Ty, you got a question?
No.
Okay. We want to construct a box, Alexis, whose base is, oh, you read this to me, Alexis, because I don't think there's any Wabash County. Why don't you start example 5? Read it to me.
We want to construct a box whose base length is 3 times the base width. The material used to build the top and bottom costs $10 per square foot. The material used to build the sides costs $6 per square foot. If the box must have a volume of 50 cubic feet, determine the dimensions that will minimize the cost.
Oh my gosh. I'm going to draw a picture of a box. Okay? And I never draw it far enough down. Is that okay? So what are the dimensions of a box, Alexis? What are they called?
Length times width times.
Okay, so can I call this length?
Yeah.
Can I call this width?
Yes.
Can I call this height? Would that be appropriate for you? Okay, so what is it that we're trying to minimize? What is it that I'm going to take the derivative of? The cost. So I'm going to call it C. Does that make sense? So I first figure out my primary function. I'm going to call it C here. And now I have to create it. And it says this: the material used to build the top and the bottom costs $10 per square foot. Isn't that what you said, Alexis? So it's times. Well, here's the bottom. Would you agree with that? Alexis? So this is, how many square feet is this bottom? No, it doesn't give me any number. So what am I going to say it is?
Length times width.
It's length times width. Would everybody agree? What about the top here?
Also length times width.
So there's 2 of them. So there's 2 length times width. Everybody with me on that? $10 per square foot for the top and the bottom. This is how many square feet are on the bottom, length times width. The top is going to have the same length and width, correct? So I multiply it by 2. Elijah, are you okay with that? Okay. Plus, now it says the material to build the sides. Well, here's a side. I call it the right side. And that's $6 per square foot. And how would I compute its square footage, Alexis?
2 height times length.
It's going to be 2 of them. And you said height times length?
Yep.
And why are there 2 of them?
Because there's another side.
Because the left side is exactly the same. Everybody agree? Now, I have another side, Alexis. I have the front. It's also going to be 6, correct?
Yes.
And how would I compute its square footage?
2 height times width.
2 height times width. All right. It is messy. Ugly, ugly, ugly messy. So I'm going to see if I can make it better. I got 20 LW I have 12 HL, and I have 12 HW. I have 1, 2, 3 independent variables. I want to get it down to 1. Allison. Do they give me any clues on how to get it down to 1? Read very carefully. If they didn't give you a clue, then these people should be taken outside and horsewhipped. A horse should be there with a whip, whipping them. Okay, I don't know how that would work. I don't think it'd be very successful. Okay, so no clues at all?
It says that the base length is 3 times the base width.
Oh, L is equal to 3W. Length equals 3 times the base width. So wherever I see an L, I can replace it with 3W. So I got C equals 20 times 3W times W. Does that look okay? Plus, I can't do anything here. 12H. Oh yeah, I can. 3W here. Right? I can't do anything here. Okay, let's see if I can make this nicer. I got C equals 60 Allison W squared. Does that look correct? And here, this is going to be 36 HW. Ooh, I got 12 HW, so I could say it's 48 HW. Correct? Owen, a little nicer.
Yes.
Still poopy, though. I got 2 independent variables. Allison, it'd be nice to get rid of H. Do they give us any more hints? We took care of this hint, right? Do they give us any other hints? Finding those hints can draw you towards insanity, just to let you know. Just giving you a little warning, okay?
The volume has to be 50.
Oh, volume, 50. How do you compute volume?
Like times
Length. Oh, length is 3W. Times.
width,
Times.
height.
Ooh. So I get 50 equals 3W squared H. Correct? Is that helpful? Okay, tell me what H is.
50 divided by 3W.
Perfect. 3W squared. Right? So now I got C of W. Would you agree? I have created a function that I can input a W and know the volume. Know the... Oh, not know the volume. Know the cost. C stands for cost based on width. Equals 60 W squared plus 48 HW over 1. I'm putting it over 1 because this thing is a fraction. 3W squared. Justin, does that seem decent?
Yeah.
Can I simplify anything over here?
You could get a common denominator.
Multiplying. I don't need a common denominator.
Why is there an H in the 48 HW?
Because I was being...
Okay.
Yeah, because I replaced that H, didn't I? Yeah, that H should be gone. It should just be 48W, right? Sorry about my messiness. It's 48W, and here's H, correct? Okay. Now, can I simplify anything here, Justin? Good thing you're here, Caitlin, to keep me on the straight and narrow.
You could get rid of a W.
And get rid of this W that I've already messed up anyway, right? Right? Okay, anything else? Does 3 go into 48? Do you know how you can tell 3 goes into 48?
Add up to
Yeah, what's 4 plus 8? Yeah, so it's got to go in there, right? Do you know how many times 3 goes into 48? This one, it took me a long time to know this. I hate to admit it over the abyss, but it did. I bet you I didn't get it down till I was like 26. And I'm asking you to know. And you're not 26, are you? No, I didn't think so. 16. You got ways to be. You got 10 more years, right? 3, does it go into 48, anybody? 16 times? So I got CW equals 60W squared plus. Here's W on the bottom. What is 16 times 50? What's 16 times 5? You guys go to the machine so quickly. 800, I think. Am I right? We've seen this problem before, Aiden. I think Landry had one like this. Maybe. I'm not sure. Maybe not. Because we got to take the derivative, correct? So what's the derivative of 60W squared? 120W. What is the derivative of 800 over W? Remember, 800 W to the negative 1, correct?
Wouldn't it be minus 800 over W squared?
Perfect. 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 And so I got to get a common denominator. Now I get a common denominator, Justin. Now I get a common denominator. What is the common denominator, Justin? W squared. And so I got to multiply this by W squared, and this becomes W what? W what? Cubed. So I look in the denominator and I say, hey, W can equal 0. Can it equal 0? What do I know about W? Can it be negative? Can it be 0? Because I want to have a box. Right? So W's got to be bigger than 0. So that can't happen. So Aiden, how am I going to solve this? Because I don't have a lot of room anymore. I'll give you a hint. Where else? I looked to see if the denominator could be 0, and it's not. So where's the other place I'm going to let equal 0? Numerator. So I have 120 W cubed minus 800 equals 0. So that means W cubed is equal to what, Aiden? So W has got to be equal to the cube root. Now we'll want our calculators of 800 over 120. Correct? Right? And you guys got machines, and we'll wait. We'll wait till tomorrow.
Spoiler alert, 1.882.
Somebody yelled out, W equals 1.882. We'll write that down in case I forget.